Alright, this is the Lesson 1, Module 1 video, and in this video we're talking about constructing an equilateral triangle. In the opening exercise, we have two people playing catch, and a third person joins them, and they all want to stand so the distance between any two of them happens to be the same. So if we put a little point on the board for the first two people, Joe and Marty, we know that the distance between Joe and the third person is going to be the same distance as Joe and that second person, Marty. So the best way to do that is with a compass making a circle. The reason for that is in this circle, every point on the circle is the same distance away from Joe that Marty is. Now, if we have that same relationship from Marty to the third person, I want them to be the same distance away these two guys are, we're going to make another circle which shows all the possible points that that third person could stand, so that's the same distance apart. And if we do that, we see two different locations on the graph where this third person could stand. Up at the top where these two circles intersect, and in that second intersection down at the bottom. Either one of those third points ends up making an equilateral triangle for us. Now we know that because in a circle, every radius is the same distance. That's something that kind of comes back later on in Module 5. So that's the definition of an equilateral triangle, a triangle with all three sides having the same distance. And if we wanted to, we could have drawn in a second equilateral triangle from the second option. Example 1 kind of covers a similar theme here, where we have three cats in a room, and they all want to be kind of spaced apart equally. So I'm going to bring my compass down from the example up top, and we're going to do the same thing. The compass goes on one of those 2 points, representing one of the 2 cat locations. We put the pen or pencil of the compass on the other location, and we draw a full circle. If we do the same thing from the other point, kind of flip the compass around, draw another circle with the same radius, we get 2 possible points again where that third cat could go. But in this question, only one of those points is actually inside the room. So the only point that actually makes sense is the one that's on the bookcase there. Page 2 here is just some of the basic vocabulary we need for geometry, points, lines, segments, and I'm just going to reveal those diagrams that kind of match the definitions on the side there. So if you want to go ahead and pause the video, you can copy down the diagrams we have on the right side. And I'll move it down so we can copy down the diagrams for the lower half of the vocab words. Again, to copy any of these, just pause the video and write down anything you need or missed from class. At the bottom here, we have copying a line segment, which comes up in a lot of the constructions we're going to see this year, so we'll kind of go through the steps on how to do that. To copy a line segment, first, use your straight edge of the ruler or compass that you have to draw a line, preferably longer than the line segment we're copying. Any straight line you draw has to be using the straight edge. You can't do it freehand for the constructions chapter. To copy segment AB, we're going to take the compass and put one end on A and the second end on point B, and just make a little mark on the segment showing that we have that distance locked in our compass. I'm going to take that compass without changing how wide it is, put it on the end of my segment, and just do the same exact measurement. And after I do that, because this is a copy, I'm going to call the left end A prime and the right end B prime. Those just signal that I have the same segment copied down on my new segment. And I cross out the rest of it, showing that we didn't really need all that distance there. Page 3, we're going to skip. This is an extra homework question in addition to the homework on page 5. So we're going to skip past to this page here. And we're going to look at example 3. Example 3 goes over some details in how the constructing of a equilateral triangle works and some things that happen from that. So in A, they're asking us what's special about points D, E, and F. Because of the way that we construct these circles, E, F, and D in the bottom are actually midpoints of this big triangle here. Again, every radius in a circle is equal. They're the same length. So each of these distances are equal. So E, F, and D, all midpoints. If you use your compass, you can kind of measure the distance from E to C and E to A to verify that they are the same. Part B wants us to draw DE, EF, and FD, something that we will eventually call a mid-segment, but we're not there yet. So our original triangle kind of breaks down into 4 equal triangles. Because of that, all those little segments there are also equilateral. Each triangle that we see there is an equilateral triangle. What is special about the 4 triangles within ABC? We kind of mentioned that, but all 4 of these triangles, and I'll number them, 1, 2, 3, and 4, all of them end up being equilateral in that picture. And D, how many times greater is the area of ABC than the area of CDE? Although we can't get a number area for this, if I write down area of triangle ABC and area of, and I'll pick any one of the 4 smaller ones, I'll pick AEF up top, whatever the area for ABC is, I'll pick some unknown number K. Because we split it into 4 equal parts, the area of the smaller ones are all going to be K over 4. All right, that's the end of the lesson. Please do your homework and stay in school.